What's going on, guys? In this video we are going to see an example on Thevenin's theorem. Here the question is asking to find the current across this load resistance, and also here we have a linear circuit. And Thevenin's theorem is basically when we have a linear circuit we can change the circuit into a Thevenin circuit, so we can find out whatever the things they are asking for. So here the question is asking for the load resistance, and let's see how we can change this linear circuit into a Thevenin circuit. Now to do that one, what we have to do is we have to find the R Thevenin and V Thevenin. To find R Thevenin, what we do is we just remove the load resistance and remove the current sources, and we short the voltage sources. And let's see how is the new diagram is going to look like. So when we short the voltage source, that's going to be a straight line, and the resistance are going to just remain the same. So we are going to have the 6 ohm resistance right here, and we remove the current source, so that's gonna look like this. And then this here we have another resistance that is 6 ohm, and also we have another resistance that is 4 ohm, and we remove the load resistance, so that's gonna just look like this, right? And if you notice, this 6 ohm and 6 ohm is in series right now, so we can combine them together. That's going to be 12 ohm. So we have 12 ohm right here, and we have 4 ohm right here, and these two are in parallel, so we can find the equivalent resistance by simply multiplying those two and divide by the addition. 12 times 4, 48 divided by 16, 48 divided by 16, 16 times 2, 32, 3, 40, so it's equal to 3 ohm, right? So the equivalent resistance is going to be 3 ohm. This is going to be just 3 ohm right here. Okay, now we found out the R Thevenin, so this is going to be the R Thevenin. Now let's see how we can find the V Thevenin. To find V Thevenin, what we do is we remove the load resistance and we find the voltage across the open. So when we remove this one, here we are going to have an open place, and we have to find the V Thevenin across that one. Now let's go ahead and do that. Let's draw the circuit for this one. This is going to be plus minus 12 voltage, and then the 6 ohm is here, and we have this 2 ampere current source is here, and we have this 6 ohm resistance is here, and also we have 4 ohm resistance is right here. We remove the load resistance, so it's going to look like this. And here what we can, so this is V Thevenin across this one, V Thevenin, and here what we can do is we can take this node as V. So let's say this is V. Okay, now we are going to find the voltage V. To find that one, what we can do is we can use a nodal analysis technique. To do nodal analysis, what we do is we use the Kirchhoff's current law, and from this one we can see the current is entering this node I1, and this one also entering I2, so this one should be exiting, so this is I3. So from this one we can see that I1 plus I2 is equal to I3. Now let's write this one in terms of voltages. I1, so we have the current already, so we can just put that one right here, 2. This I2, okay, I2 is 2, and I1 is going to be 12 voltage, and this V, 12 minus V divided by the voltage across this one, resistance across this one, so that's going to be 12 minus V over 6. And then I3 is going to be, here we have totally we have 10 ohm, right, 10 ohm, and V minus 0, so V over 10, that's going to be the I3. Now to simplify this one, what we can do is we can multiply this one by 30, so we can get rid of this 6 in the denominator and 10 in the denominator, and that's going to give us 60 plus this is going to turn into 5. So 5 times 12, that's going to be 60, minus 5V is equivalent to 30 times this, that's going to be 3V, and totally we are going to have 8V is equal to 120, right? 8V is equal to 120 over 8, 120 over 8, 1, 4, so 80, 40, 40, so this is going to be 15, right? V is going to be 15 voltage. Now we found out V is equal to 15 voltage, but our purpose is to find the Thevenin. So if this is Thevenin, this is also Thevenin. So we can find the Thevenin right here. Now voltage across this one, we can find it by remaining resistance, that is 4. So we multiply this V by remaining resistance is 4 ohm over the total resistance, that's 10 ohm. So 15 times 4 over 10, and that's going to give us 60 divided by 10, that's going to be 6 voltage. So Thevenin is 6 voltage, right? Now we can go ahead and draw our new circuit in terms of Thevenin, Thevenin and Thevenin. Let's go ahead and do that. So here we are going to have Thevenin, we found out that is 3 ohm, right? So Thevenin is going to be just 3 ohm, and Thevenin we found out that is 6 voltage. Okay, so this is 6 voltage right here, and that is Thevenin. And also we are going to have the load resistance RL, that is equal to 15 ohm, and here we are trying to find the current across this load resistance. Since this is in series, we can find the current easily because current everywhere is going to be equal, and we know that current is equal to voltage over resistance. Here it's going to be R total, voltage is 6 divided by R total is going to be 15 plus 3, that's going to be 18. So 6 over 18 is going to be 1 over 3, and that is equal to 0.333 ampere, and that's going to be the current passed through the load resistance. I hope this helps. Thanks for watching.